right, here we go. We're going to talk. We're doing section 3.3, and I'm going to write down what we're doing here. Let me get my marker all ready to go. Okay, here we go. And we're going to talk about the slope of a line. Do you remember doing this in Algebra 1?
Oh, yes.
Yes. Slope. We're going to start off nice and easy. We're just going to do slope today. All right, the slope of a line. Basically, the slope of something means just how steep is it, okay? How steep is it slanted? And there's a way to figure out how steep this thing is. Watch. If I did this, if I measured how far up and down I go compared to how far across I go, hear what I just said? If I measure how far up and down I go compared to how far across I go, that gives me... I'll stop and wait for a second, make sure everybody's with me. I won't say any names to protect the innocent, but I'm looking at you. Okay. Alright, so watch. So we compare how far up and down we go, and we compare it. Now when I do a comparison in math, a comparison means it's a fraction or a ratio. You ever hear that word before? Sure. Okay, it's a comparison. We compare how far up and down you go to how far across you go. Watch this. I could have a line that goes like this. Okay? Now look at that. Look at the difference. There's a big difference, isn't there? On how steep it is. Look at the comparison. The comparison of how far up and down I go to how far across I go. This is quite a bit bigger, isn't it, than this? This is what? Smaller than this. Do you see? So those numbers make a difference on how much of a slant that it has, or the slope of it. I'm not a real big skier, but I love to ski. If I had a lot of money, I'd buy my own equipment and I'd go skiing all the time if I had the time. I don't. I don't have time, I don't have money, so that's why I don't go skiing very much, okay? But I love it. Every once in a while I get a chance to go, and it's a blast. So when I think of slopes, I think of going skiing. Who's been skiing before? Anybody been skiing? Only 4 of you? Okay. How'd you do? Anybody break a leg or anything? No? It's a blast. I love it. I love going down the hill and the wind, you know, and you're all scared and your heart's pumping if you go too fast, and it's always exciting. But, and then you hit a tree. Well, I haven't done that yet. So anyway, when I think of slopes, let's listen now. When I think of slopes, I think of going skiing. All right? When I first went skiing, I went down the bunny slope. You know what the bunny slope is? I don't know why they call it that. I don't think they have an official sign that says this is the bunny slope, but that's what people refer it to. Okay, there might be, I don't know. But the bunny slope is more like this one. It's not as high as it is across. Do you see it? So it's not as much of a slope. So you kind of go a little bit slower down this hill. You follow me? Now, when you get pretty good, then you go to the top and you see these things. You know how they label those skiers? What do they label the highest, the hardest one? The black diamonds, right? For some reason they use black diamonds. Almost every, I guess it must be a universal code, you know, when you go to ski slopes and stuff, so people know what's the easy one and what's the hard one. The black diamonds, the double black diamonds, are always like the hardest ones, and they'll look like this, right? You're standing here. Here's you, right? You're on skis. There's your skis right there, okay? I'm not much of an artist. But look, you're looking down a hill like this, and I tell you what, your heart starts beating, you know, and you're like, wow, I can't believe I'm going to go down this thing. So, but there's a big difference, isn't there, in the slopes, right? And we'll talk a little bit more about skiing in a second, but right now we're just talking about this. So if I compare what they call this, a lot of times they call this the rise, how far up and down you go, okay? What's the other one called? Yeah, see now it's coming back to you, right? Yeah. Let me get rid of this nice drawing I've got. All right, so this is the rise, and we call this the run. So when we talk about the slope, we talk... Remember I said the comparison is? We compare what to what? The rise to the run. So when we talk about the slope of something, I compare. It's a comparison. It's a ratio of the rise to the run. And this is the slope. Okay, slope is equal to that. Now they use a letter. Do you remember what letter they use? No R. You'd think they would use an S, wouldn't you? Because of slope. No, they don't use P. No T. Eventually we'll get it, I think. Nobody really remembers, though, do they? right, they use M. They use the letter M to represent the slope. Okay. All right. It's the whole ratio. The slope is M, and it represents the whole entire ratio of the rise to the run. All right. That tells you how steep your line is. Listen now. So the higher your number, look, as the rise gets bigger and bigger. So for instance, if I had 7/2, right? That's a large rise to a small run. That would be pretty steep, wouldn't it? All right, compared to, let's say, a 2/7. What about 2/7? 2/7 would be a little rise and a long run, so that wouldn't be as steep at all, would it? All right, this would be a lot. This would be the bunny slope. This would be the double black diamond right there, if you want to think of it that way. Okay. Now, why do they use the letter M? I actually looked it up one time, and they really don't know where it came from exactly. They have an idea. I think I believe, if I remember right, it's been a couple years since I looked it up, but I believe there's a Latin word starts with M, and it has to do. It has to do with, there's a word, and I forget exactly what the word is, but it has to do with mountains. The word mountains comes from, the steep mountains and stuff, and it's an M. It doesn't really stand for mountain, but there's a Latin word, and it means something about how steep something is. I don't know. But it doesn't matter. But that's where they get the M from, all right, if you're wondering. I always wondered, why M? I never learned that in high school and college. Nobody ever tried to explain to me, and I really haven't explained it to you that well either. But you've got Google at your fingertips, don't you? Go to Google. It's an amazing thing. Something I could have never done when I was in high school or in college or my first bunch of years teaching. I could have, because it didn't exist. There was no internet back then, okay? Google did not exist. No, it's only existed for the last few years. I had to go to the library, that's right, or you had to look it up in a book, or you had to ask somebody that might know. Yeah, and actually crack open a book. All right, enough fooling around. Let's work with this thing. Let's go a little bit more detailed with this. All right, let's pause this for a sec. All right, let's take a look at this. Let's talk about slope again. We said the slope is the rise over the run, but what I'm going to do is I want us to think about an x and a y axis. Let's make that look a little bit more even. That's a little bit better. Okay. So what I'm going to do now is let's put a line in here. And I don't care about exactly where it is. Let's just make it slant like that. All right? So what I'm going to do is this. Watch very carefully. I'm going to take one point and another point. It doesn't have to be the end points because this is a line. A line keeps on going forever, doesn't it? So I just take 2 points. If I want to find the slope of this, I can take any 2 points. You hear what I said? I can take any 2 points on this line, and if I find out, what do you think? The rise over the what? The run, then I can find the slope of that line. All right? So this is a point right here. We'll call this x1. Let's make that a little bit bigger. We'll call this, what do you think? x1 and then what? y1. Good. And this point down here, this is my second point, so I'm going to call it x what? 2. Good. And y2. So I'll call that x1 and y1, x2 and y2. You with me? So if I wanted to find the rise of this point, first of all, if we go up, this would be the y1, wouldn't it? Right here. And then down here would be what? The y2. So that would actually be the y2 right here. What would the x be? See, if I go over this far, this would be the x1. If you don't understand that, that's fine, but trust me. All right? What's that? Okay, I said that's fine. All right. So don't worry about how we got that point right there. If you recognize it, that's fine too. So that point right there, look, we went over. How far did we go over to get to this point right here? We went over x1. How far up did we go? I said y1, didn't I? That's not right. Let me change it to that.
Lindsay Padilla, please come to the office.
No, that's right. Yeah, it's y2. Did I say y2 before? Yeah, that's what I thought. Okay, that is right. So I go over x1 and I go up y2. That's that point right there. So what I'm going to do, I want to find the rise over the run. How do I find the distance, okay, just straight up and down, from here to here? Well, you don't even have to use a distance formula. If it's straight up and down, watch. If this was 5 and this was 3, besides counting, yeah, what did you do?
I minus 3 from 5.
I mean, you could count, couldn't you? 1, 2. Okay, but it's a lot easier just to go what? 5 minus 3. Agreed? What if I went from here to here? Let's make it a little bit tougher. What if I said this was -2 and this was at 4? What would I do there? Could I count? Sure, I could just count over, but what's a better way to do it? Subtract. That's right. Look, you just subtract. So it's 4 minus what? -2, which is 6. So what's the distance here? It's 6. What's the distance of this? It's 2. Look at this. Where am I here on the y-axis? I'm at y1, aren't I? Where am I down here on the y-axis? I'm at y2. How do I find the distance between them? y1, no, I'm up and down, not x. It's what? It's y1 minus y2. That's the distance from here to here. That would be the what?
Rise.
The rise. Look at the run. Where am I here? I'm at x2 here. Where am I here? I'm at x1. How do I find the distance or the run? That's right. Now, I'm going to do it in the same order, though. I'm going to go x1 minus x2.
Yeah, you just wrote
Okay? Right. All right, so watch. If I want to find the distance from here to here, I subtract the y's. If I want to find the distance from here across the run, I subtract the x's. All right, so watch. Here we go. If I want to find the slope, instead of saying rise over run, let's use our x's and y's. What would it be? What was our rise? y1 minus y2. What was our run? x1 minus x2. Look, right there. That's really, really important. You got to know how to do that. That's not us. That's your slope. Do you understand what we're doing? We subtract the y's and you put it on top. Listen, I'm going to say this a whole bunch. This is the first time that I've said it, but I'm going to say it a whole bunch. Get it right off the bat. This means you subtract the y's, you put it on top, and you subtract the x's and you put it where? On the bottom. How can you remember that the y's go on the top? Because this is rise. Rise is the y-axis, isn't it? It goes up and down. What's the run? The run is the x-axis. So rise over run, it's y over x. Does it make sense? A lot of people, I hate to even say this because I don't want to even stick it in your head, but I think you can deal with it. A lot of people put the x on the top because they're thinking, oh, x goes first, right? So x is on the top. But it's not for the slope. The slope is the rise over the run. It's how far up and down you go on the y-axis, and it's how far across you go on the x-axis. Are you with me on that? So write that down. Make sure that's somewhere. All right, let's do a little example here and of something that they're going to give you, and you need to figure out how to work this out. All right, so let's pause this. All right, here's our situation. Here's our graph, and they're going to ask you to find the slope of the line. You see, they show you where this point is right here, but if they didn't show you where that point is, you could kind of look to see where it actually crosses. Do you see it? I call these little grid marks, I call them little crosshairs. Do you see it? Where they cross right there. So you can see it crosses here and it crosses right there. So what is this actual point right here? You can do this two ways, and I'm going to show you both ways. 3, 3. And what's this point down here? No, -1, -2, -1, -2. You could do it two different ways. If you have a graph like this, I think, to tell you the truth, I think the easiest way is just to count. Let's do rise over run. So start from here, and how far are we going to go? We're going to go all the way to here. Little squiggly line, but I'll tell you what, let's make that dotted. Okay, so we're going to count to here, aren't we? And then we're going to count across. All right? Now, if you count down, what do you think? You're going to go negative, aren't you? If you count to the left, it's going to be negative. All right? So let's do this. Let's count. 1, 2, 3, 4, 5. But we went where? We went down, so that's -5. Now you're here. That's my rise, isn't it? What's the run? Start here and go 1, 2, 3, 4. Which way did we go? To the left. All right, so that's -4. Now, how do I find the slope? That's what they're asking for. The problem says find the slope. Okay, so it's just what? -5 over -4. Are we going to keep it negative over negative? What is a negative over negative? So keep it 5 over 4. Do not, listen to me, do not make that to a mixed number. Keep it improper. You got it? Don't change slopes to mixed numbers. Don't change them to decimals. Keep them improper. And that's how you find the slope.